Hello everyone, this is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Autonomous, Visakhapatnam. In this session, I am going to discuss method of variation of parameters, part 1. Coming to the learning outcomes. After successful completion of this lesson, the student will be able to solve linear differential equations, solve the linear equation of second order with variable coefficients by using change of dependent variable when the part of complementary function is known. Solve the linear equation of second order with variable coefficients by using variation of parameters. Linear differential equation of order n. An equation of the form, this is a nth degree differential equation, an equation of the form, this is a form where a0, a1, a2 and so on, an and q are constant continuous real functions in x defined on an interval I is called a linear differential equation of order n over the interval I. Coming to the another definition, an equation of the form that is second degree differential equation d square y by dx square plus p of x into dy by dx plus q of x. P of x means p in the form of term in the variable x. The same way q in the variable y into y is equal to r. That is r also in the form of x, where p, q and r are real valued functions of x defined on an interval I is called linear differential equation of second order with variable coefficients, right? Now in this, P and Q are real constants. If they are real constants, the linear equation can be solved by the method already we discussed, by the methods discussed in the previous chapter. Otherwise, there is no general method known to solve the linear equation of the second order with variable coefficients. Now coming to the, in this lesson, we discuss some methods which at times will yield a solution. Now linear equation of second order with variable coefficients can be solved by the following methods. So given can be solved by the two methods. First one is a change of dependent variable when the part of complementary function is known. And second method is variation of parameters. Now coming to the next one, what is the first, we are going to discuss with the first method. Change of dependent variable when part of complementary function is known. So I have given the some working rule here. What is the working rule? Some steps I have given. First we are to, this is a working rule to solve. This is a linear equation of second order with variable coefficients. That is d square y by dx square plus p into dy by dx plus qy is equal to r. Now first, what is the first condition? First step, what we have to do? Reduce the given equation to standard form as d square y by dx square plus p into dy by dx plus qy is equal to 0. Right? So first of all, we have to reduce whatever the given equation, second degree equation, we have to reduce like this. Main thing is LHS. So we have to reduce in the form of the LHS like this. Here the RHS may be 0 or R we can take. Let it be, this is equation 1. Now second step is either a part of complementary function is given or it can be found by inspection method. Let it be y is equal to u. Right? Now coming to the third step, let y is equal to u into v be the general solution of the equation 1, where v is equal to f of x. Now coming to the fourth step, then on differentiating this equation, on differentiating y is equal to uv, we'll get this one. Let's differentiate with respect to x, we'll get this equation. In the same way, again if we differentiate, that is second, apply the second differentiation, then we will get this equation. Now coming to the working rule to find the part of complementary function by inspection method. By inspection method. Suppose the complementary function of the differential equation, if we are like this. So using the inspection method, what are the working rules? Suppose if we have the y is equal to x is a part of complementary function. Suppose if we get the complementary function y is equal to x, if so complementary function, this becomes a complementary function, then if we have the complementary function like this, y is equal to x, if is any differential equation is the form of p plus qx is equal to 0, then then we can take the complementary function y is equal to x is a part of the complementary function. Suppose if we have 2 plus 2 into p into x is equal to qx square is equal to 0, if we have like this, then if we take the complementary function as y is equal to x square is a part of the complementary function. Suppose if we have 1 plus p plus q is equal to 0, then y is equal to e power x is a part of the complementary function. If 1 minus p plus q is equal to 0, then y is equal to e power minus x is a part of the complementary function. Now coming to the problems. Solve. So suppose the differential equation, the equation is given like this. Solve dx square y double dash minus 2x into 1 plus x into y dash plus 2 into 1 plus x into y is equal to x cube. No, using the first, this is a solution. So first of all, take the given equation as it is. Given equation as like this, right? This is a given equation, second degree linear equation with variable coefficients, right? Now we have to convert this equation in the form of this one. That is d square y by dx square plus p into dy by dx plus qy is equal to r. Any linear equation with a variable second degree equation, compare this equation with the form of like this. That's why convert the given equation in the form of like this. Means the here y d square y by dx square coefficient is unity, that is 1. So but whereas here x square is there, that's why we are going to divide the entire equation with the x square, first step. So what we got it here, y double dash minus 2 into 1 plus x by x into y dash plus 2 into 1 plus x by x square into y is equal to x. Let it be, this is equation 1, right? Now after that, compare this equation with the general equation of the linear equation of the variable coefficient, this one, right? Now compare this equation with this. From that, what will get? P is equal to this is a value, q is equal to this is a value, and r is equal to x, right? Now simplify p, q and r. Now here consider we have the, in the previous slides what we have shown here in the previous slides, by inspection method, if we have the linear equation like this with variable coefficient, second degree equation, so we have the complementary functions if we have the equations like this, linear equations like this. So according to that, if we consider p plus qx, if we get this value as 0, then the complementary function becomes a y is equal to x is a part of the complementary function, right? So clearly the first step itself we got 0, that is p plus qx we got 0, then y is equal to x is becomes a part of the complementary function, right? Now let it be, if y is equal to x is a complementary function. Now after that, what is the next step? Is the already we have given the working rule, no? So second step is, let it be the equation as y is equal to u, right? Now in this, take the u as x. So therefore the general solution of 1 is y is equal to u v. This is always a general solution of the given equation, right? Now after that, what is the next step? What we have to do? Differentiating the general equation, general solution, right? Differentiating with respect to x, we will get this one again. Second differentiation also we have to do. So again differentiate this equation, we will get the second equation like this, right? On substituting these values, substituting these values in equation 1, we get d square v by dx square plus p1 into dv by dx is equal to r1. Whereas what is the p1? We have to take p1 is equal to p plus 2 by u into du by dx, right? So these two equation where we have substituted here in equation 1, this is equation 1. After substituted those given values, these two values, so we got this equation. Whereas what is a p1 here? This is a p1. What is r1? This is a r1, right? Now here substitute those values here, P1 and replace P1 and R1 with the help of these two. So we got like this. Now simplify, what in again substitute what is a P. Substitute what is a P. Already we have taken in the previous slide P, and what is R is substitute. Now simplify. If you simplify, we will get the above differential equation like this, second degree equation. D square V by dx square minus 2 into dV by dx is equal to 1. Right? Again substitute dV by dx as V. So then what will get if you take dV by dx as V, then automatically d square V by dx square as dV by dx. Right? Now substitute these two values in our differential equation, second degree equation. We will get dV by dx minus 2V is equal to 1. Right? So this is a linear equation in V and X. Right? So on comparing it with the linear equation of the form, we get P is equal to minus 2. So this is compare this with the linear equation. So we will get P is equal to minus 2 and Q is equal to 1. Right? So from that, find out the integrating factor. It's a little bit lengthy but easy only. So don't afraid. So integrating factor. So using the P and Q, you can find out the integrating factor. Integrating factor formula is e power integral of P dx. So whereas P is equal to minus 2. So substitute P is equal to minus 2 here. So e power, this is integral of minus 2 dx is minus 2x. So e power minus 2x. So therefore the general equation, the general solution of equation 2, this is equation 2 is given by V into integral of this. We know already, we have discussed in the previous chapters. General solution of the equation is the linear equation is, this is V into integrating factor is equal to integral of Q into integrating factor dx plus C. Right? Now for substitute integrating factor here, simplify this. Now replace V by dV by dx. Now into integrate e power minus 2x is equal to integral of e power minus 2x is e power minus 2x by minus 2 plus C. Right? So this is nothing but simplify this, dV into e power minus 2x is equal to e power minus 2x by minus 2 into dx plus C dx. Right? Now again simplify that equation, we will get dV is equal to minus half into dx plus C into e power 2x dx. On integrating, we want a V, that's why we have to integrate the above equation. We will get V is equal to minus half into x. This is minus half, this is a minus half, here is the minus is there. Minus half into x plus C into e power minus 2x by 2. Right? So therefore the general solution of the given equation 1 is y is equal to u. Already we have taken the general solution. So in the beginning we wrote what is the general solution? Y is equal to uv. Right? So already we got v, and also u, we have u is nothing but x. So therefore y is equal to x into u is nothing but x into v. This is a v. So simplify that. This is a required general solution of the equation 1. Right? That is about the first problem. Now coming to the second problem, almost the same, similar to the first one only. This is a given equation. Now compare this with the linear equation of the second order with variable coefficient, this equation. Now this P is equal to, from that we will get P is equal to Q is equal to, now for finding the complementary function, so take the equation as 1 plus P plus Q. So if we take this is a trial and error method only. We using the 4 methods. You can substitute which one is satisfied, take that one. From that we take the complementary function. So here we got the complementary function as y is equal to e power x. Now after that take y is equal to u. From that u is equal to e power x. Here y is nothing but, whereas in the previous problem we got y as x, that's why we have taken u is equal to x. Whereas here y is equal to e power x, so that's why we will take u is equal to e power x. Now from that we will take the general solution of 1 is y is equal to uv. Now differentiate 2 times, we will get the 2 equations. Then after that, and substituting these values in equation 1, we will get this is the equation, whereas P1 is this and PR1 is this. Now substitute P1 and R1 in these equations. After that, replace P and R also. Simplify that. We will get equation as dV by, put to dV again. So we will get the differential equation of second degree equation as like this. Right? Now in this, take dV by dx as V, and d square y by dy by dx as V, and d square y by dx square as dv by dx, right? This is a dy by dx as V, right? Now substitute these two values in this equation. We will get this equation as like this. Let it be equation 2. So this is a linear equation in V and X, right? Now on comparing it with the linear equation form, we get P is equal to 2 minus cot x, and Q is equal to sin x. Now from that, find out the integrating factor. We will get the integrating factor as this one, e power 2x by sin x. So general equation of second equation, equation 2 is given by V into integrating factor is equal to integral of Q of integrating factor into dx plus C, right? So simplify this, we will get the equation as like this. After that, replace capital V by dv by dx. So dv by dx is also substitute. Further simplify, we'll get the equation again. For finding V, we have to integrate it. If we take the integration on both sides, we will get V as like this, right? V. So from that, we'll get the general equation. Already we have taken the general equation as y is equal to uv. So then from that, v is equal to substitute u value. So u is nothing but e power x, and v is just now we got it, v, and substitute it, simplify this, then we'll get the required equation, general solution of the equation 1. Now coming to the another differential equation, we have to solve this one. See, when compared to the first two problems, here the R value is given 0, and given y is equal to x is a solution also given. Now given equation is, this is the equation. Now dividing the given equation with x square, because we have to compare with the linear equation of second order with variable coefficient, that equation. From that, we will get p value as minus 1 by x, and q is this one, r is 0. Right? Now given y is equal to x is a solution, directly no need to find out the complementary function, and no need to satisfy all the four conditions. Any one of the four conditions, directly are given complementary function y is equal to x is a part of complementary function. So from that, u is equal to x, we got it. Now from that, general solution of 1 is y is equal to uv, and differentiating it, we get dy by dx is equal to 2 times we have to differentiate. Right? Now substitute these two values in our equation, second degree equation. We will get this. Then after that, replace P1 and R1 in the second degree equation. Again, we have to replace P and R. We will get, these are the equation. This is a final equation. This is the equation of the second degree. Now after that, again, substitute dv by dx, whereas in the previous, so there also, so same procedure, dv by dx we are going to replace by capital V, and d square by dx square dv by dx. Now here, again differentiate, d square by dx square, we will get the e. Here, d square, we basically in the previous slide, but we have taken dy by d square by dx square and dv by dx. Dy by dx is, this is a value, and d square by dx square, this is a value. Now substitute these two values in this equation 1. We will get d square by dx square plus p1 into dv by dx plus is equal to r1. In this, we are taken p1 as this is a formula, this is a value, and r1 as this is a value. Again, we are going to replace in p1 p value and r value also in r1. So finally we got, this is the equation, right? So in this, dv by dx we are going to replace capital V, dv by dx as capital V. Again, d square v by dx square as dv by dx, d square v by dx square. Now in place of y, here we have to take v, d square v by dx square as this one, right? Because dv by dx, if you differentiate again with respect to x, we'll get this one only, right? So replace y by v, not here y, it is a v. This, in this value we are going to substitute. So simplify, substitute those two values here. So we'll get the equation 2 as like this, right? Now again dv by dx is equal to, from this this one. Now compare this with the linear equation. After that, find out the integrating factor. So integrating, on integrating, we will get the, not integrating factor. First to integrate, we want v value. So integrate on both sides, we will get the v, right? So this is a v. Now this is a general equation. V is equal to c by x. We replace capital V by dv by dx, we will get this, right? So therefore, general equation is y is equal to uv. Now in this, u is x and v is, this is a value, right? Now coming to the next one, this is also similar to the previous one. Here also r is 0, and find the general solution of y double dash. We have to find out the general solution of this also. Right, here also given y is equal to x is a solution of this is given. That is complementary function is given. Right, no, similar to here also, compare this with the our linear equation of second degree with variable coefficients. Now write down pqr. Now y is equal to x is a part of the complementary function of equation 1. This is the equation 1, this is the equation 1, right? So then y is equal to vx is a general solution of equation 1. Now from that, substitute the same differential equation, same steps we will get. Then after that, replace capital V by dv by dx by capital V. Then d square v by dx square as dv by dx. Dv by dx is equal to log x. Now integrate on both sides, we will get this. Then after that, dv by dx is equal to x log x minus x plus c1. Now integral of dv, we want v, that's why integrate on both sides, we'll get a small v. Then this is after getting small v, then find out the general solution of equation 1, y is equal to vx. This is a general solution of equation 1, right? So with that, I'm going to close this lesson, this session. This is a conclusion. In this session, we have discussed the following. What we have discussed in this session: linear differential equation of order n. What is the next? We have discussed the linear equation of second order with variable coefficients can be solved by the following methods. First method is change of dependent variable when the part of complementary function is known. Just like in the previous problems, complementary function is given in the form of y is equal to x, like that, no? So if it is known, so what is the, how to do the differential equation, how to solve the differential equation. Now what is the second method? Working rule to find the part of complementary function by the inspection method also. Using the 4 inspection methods, we have discussed the working rule of the complementary function is part of complementary function by inspection method, right? Thank you.